on your desk. Now, it is not going to move, right? It's going to stay right there. You can give a force, a push or pull to it, to make it move. What could you do to make it move? What could you do? Sydney? You could flick it, and it would move. What else could you do? Kinsler?
Blow it.
You could blow on it and make it move. The air you blow would be the force. What else? You could shake your desk, move your desk, and it would move your pencil. Very good. Boys and girls, we're recording. Y'all can all be talking at the same time, or my friends at home will not hear us. Okay, so we have to apply a force to the pencil. It must be pushed or pulled before it will move. Okay, so we already know that. Now, what about this? Can you make your pencil spin? Like this? Can you make it spin? That's kind of a push and pull using your fingers, right? There you go. You can make it spin. Take your car. Now, I'm going to set it on my desk. Can it move? No. I can make it move by pushing or pulling it. So I can push it, and it'll go that way. I can pull it to go backwards. I can make it go, push it to go backwards. I can pull it to go forward.
You can spin it.
Now, your paper cup, when you push it, it does not roll in a straight line. Does it? When you cannot roll the paper cup in a straight line. It's impossible. I want you to find a small spot on the floor, and I want you to try to push your cup and see what it does. It didn't go straight like a ball would or the car would. What happened to it, Emma? It rolled in a circle, and the reason that is this side and this side are not the same, right? This bottom of the circle is smaller, and this circle is bigger, so it can't go. So if you have a car, all the wheels are the same, right? So when they go, it goes in a straight line unless you make it go in a different line. Unless you push it to go different. Or the wheels turn. It goes straight, which those wheels don't turn. All right, so now I want you to take your cardboard, and I want you to use, we're going to use our math bins. My friends at home, you can use anything like a stack of books or something, a stack of books. No, we're going to do it on our desk, and you're going to make a ramp. So we use the math, our bins. You can use books at home, and I made a ramp. That's all I'm doing. Okay, put your name on your paper. Now, we're going to draw our ramps. We have our box, right, or our stack of books for my friends at home. And we have our ramp. And the first thing we're going to do is your ball. So grab your ball. And we're going to put it on our ramp at the top and let it roll, or however it's going to move. I should have said roll. Y'all know, though. You're going to have it go down the ramp. So start at the top and go down. Get it to go up your ramp. You might have to hold your ramp. Waterfall, waterfall. What happens when you make it go up? Then it goes back down, right? Because the force is pulling it down the ramp. All right, so go back to your papers. Go back to your papers. Which way did it go? Down. It went down. Even when you rolled it back up, it came back down the ramp. So it went down. So what kind of motion? Remember, we have three motions. Roll, spin, and slide. What kind of motion did the ball take? It rolled. So let's write that. Roll. The ball rolled. There we go. Let's put the ball up here because that's how it started. So this is my experiment. I had my box or my books, my ramp with the ball at the top. This tells me what happened when I did my experiment. It went down. This is the way it changed its position, the movement it made, and it rolled because round things roll. Okay, now we're going to do our square. So draw your ramp and just put your square up the top there. Okay, your square looks like this. Some of you, it's different colors. Okay. Now, what I want you to do, boys and girls, what I want you to do is on your ramp, I want you to see what kind of motion your square does. Your square. See what it does on your ramp. Okay, did it go to change its position the same as the ball did? Did it go in the same direction? Yes, it went down, but it did not roll this time. What did it do? What would you call that motion, Emsley? Slide. Or slid. It slid. Or slide. And it went in the same direction. It slid down. Okay, now we're going to do our car. So you get to draw your car up here. You get to draw your car up there. Okay, now when you go on your ramp, you can take your car and you can try to make it go down. You can try to push it up. You can try to get it to change direction. Now, we had our cars go up and down. It could do both. We had our cars do up and down. We had to go down and then we moved it, pushed it up, didn't we? Now, what do? Do they roll, slide, or spin? Roll, yes. The tires or the wheels roll. They roll. All right, our last one on our ramp is going to be our cup. Kind of hard to draw the cup. I guess that's the best I can draw my cup. Okay. Excuse me. Please listen. I'm just doing the cup as best I can. It's kind of a bad picture, but hey, it works. All right, now when you do this cup down the ramp, it's going to do two things. So I want you to take your cup and go down the ramp now. So go ahead and different movements. Some of you stood it up, or you put it down like this and notice that it did what? It slid, right? Some of you did this, and you noticed that it did what? Rolled. So you could do two things. Number one, we'll have to draw two of them. You can slide it down, right? And then number two, we'll have to draw a little smaller. You rolled it, but it kind of rolled in a circle, didn't it? So it didn't go straight down. It rolled in a circle like this. That's what it did. Rolled in a circle. It didn't go straight down. Because remember, one side is smaller than the other. Let me zoom in so you can see that. We did two different ways. Now we're done with the ramps. Coming around to get your ramp. Please get your ramps and hand it to me.
I'm 3 years old, so I have a great car.
Okay. The last one I have is called a top. Now we're not going to use, boys and girls, we're just going to use the top of our reading or math bin. And you're going to have the big part right here be at the top. So it's at the top. The little part's at the bottom. So you got to use your fingers to do the movement. So what you're going to do is use your fingers to go like that. Go ahead and do it. It's still going. Experiment. This is what we started with. So we have our box, and then we have our little top. I did a little point on the bottom, the circle, and a big point at the top. When things are pointed, what motion do they make? What's the movement? A roll, spin, or slide? What is it, Henry? Spin. So I'm just going to do a big thing like this. It goes spins in a circle.